Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to be talking about the mole. No, this is not the mole that burrows underground, nor is it the scary mole with hairs growing out of it. We are going to be talking about the chemistry mole. Now, I know this is a concept that many students have difficulty with, so we are going to start with a concept that's going to be a little more familiar. We are going to start by talking about the dozen. Now, if I were to ask you to go get me a dozen eggs, you would go get me 12 eggs. Now, an egg is about 55 grams, so you would bring me about 660 grams of eggs. Now, what if I asked you to go get me a dozen guinea pigs? Well, if I asked for a dozen guinea pigs, you would bring me 12 guinea pigs. Now, a guinea pig, while a lot cuter than an egg, definitely weighs more than an egg too. So a guinea pig is about 950 grams. So if you were to bring me a dozen or 12 guinea pigs, you would bring me about 11,400 grams worth of guinea pigs. Now, what if I didn't ask for guinea pigs? Let's stick with the cute animals. What if I asked for a dozen kitty cats? Well, a kitty cat, while just as cute as a guinea pig, definitely weighs more than a guinea pig. So a cat weighs about 3,200 grams. So if you were to bring me a dozen or 12 cats, you would bring me 38,400 grams of cat. The point I am trying to make is that when I ask for a dozen of something, you will always bring me 12 of whatever item I specify. Now, the mass that you bring me might vary depending on what item I want, but the number remains the same. This is the same concept that we use for the mole. The number remains the same, but the mass might change. Now, we can't use a dozen when we talk about a mole, because if we measured out 12, say, atoms of carbon, it would not register on any kind of balance. So we need a number that is large enough that will allow us to measure a number of atoms so that it registers on a balance. So if we go back to the early 1900s, a scientist named Jean Perrin used several different experimental methods along with Einstein's theory on Brownian motion, and he came up with Avogadro's number, or sometimes we call this Avogadro's constant. Now today we accept Avogadro's constant as 6.022 times 10 to the 23rd. Actually, we can get this number to about 9 sig figs, but for our purposes, 6.022 times 10 to the 23rd will work just fine for us. So if we go back to our items, instead of asking for a dozen, let's say I asked for a mole of eggs. You would bring me 6.022 times 10 to the 23rd eggs. However, its total mass would be 3.3 times 10 to the 25th grams. That's a lot of egg. But what if instead of eggs, I asked you to bring me a mole of guinea pig? That would be cuteness overload, wouldn't it? Yes, it would. So you would bring me 6.022 times 10 to the 23rd guinea pigs, and that would be a total mass of 5.3 times 10 to the 26th gram. That is a lot of guinea pig. Yes, it is. But again, instead of guinea pigs, what if I asked you to bring me a mole of kitty cats? That also would be cuteness overload. But you would bring me 6.022 times 10 to the 23rd kitty cats. And that would be about 1.9 times 10 to the 27th grams of cat. Let's step away from the cute animals and let's switch over to the periodic table. Now, the periodic table gives us the number of grams that 1 mole of a certain element weighs. So if we take a look at boron here, you'll notice its molar mass is 10.811. That means if I weigh out 10.811 grams of boron, it means I have 1 mole of boron. Of course, if I have 1 mole of boron, that means I have 6.022 times 10 to the 23rd atoms of boron. I can do the same thing with any element on the periodic table. So let's take a look at iron here. If I want to weigh out 1 mole of iron, I need to weigh out 55.845 grams of iron. Now that means I would have the same number of atoms that I did for boron. Again, I would have Avogadro's number, 6.022 times 10 to the 23rd atoms. But notice the iron atoms are more massive, therefore they weigh more. So all of the masses on the periodic table are the masses for weighing out 1 mole of any element. So again, remember, the number is the same. It's Avogadro's number. But as the atoms get bigger, their molar masses also get bigger. The mole is so important in chemistry because we need an easy way to keep track of the number of atoms or the number of molecules. It's a way for us to know how much of a reactant we might need or how much product is going to be formed. And it is so much easier to talk about needing 2.5 moles of carbon instead of 1.5 times 10 to the 24th atoms of carbon. Now, in our next videos, we are going to carry this concept of the mole forward. We're going to talk about molar mass. We're going to talk about balancing chemical equations, but we are going to use the mole over and over again. I hope you found this video helpful, and thanks so much for watching.